Okay, let's take a look at a couple more problems. So moving on right now to question number 4. So absolute values, one of the easiest concepts in math early on that becomes far more complex when you sort of add it with algebra. Remember, the absolute value makes whatever is inside positive. So that means this 7x minus 12 sitting here might have been positive 12, but it's entirely possible that that 7x minus 12 could have originally been negative 12 to start with, right? That's what happens with those problems. And I just realized I miswrote that question. It's just minus a 2, isn't it? Let me fix that. Okay, so now we're better. So if we add our 2 to both sides, we're looking at a simple answer of 2 on the left side. We're looking at, I guess when I add that, I get negative 10. So we're looking at negative 10 sevenths. Now, this is a good answer, but remember there is a slightly more formal notation where you can make the nice fancy brackets called a brace, and you make a list of all the answers that make that statement true. Now, highlighting a problem that, again, came off of that group quiz you did, when you have not just an isolated absolute value, but you have some absolute value that's got some extra little pieces in there, you want to start by getting that absolute value all by itself. So I added the 2 to both sides, and I went ahead and I divided both sides by 5. Now, in this case, unlike the quiz, this is a valid problem because absolute values make things positive, which this problem is. So we're going to do 4 minus 3x equals 9/5, or possibly 4 minus 3x equals negative 9/5, just like the previous question. We're going to do just a little bit of quick arithmetic. We're going to subtract 4 from both sides, and 4 is really negative 20/5, so I'm going to have negative 11/5. And if we divide both sides by negative 3/5, I'm going to get 11/15, because that 3 is really going to just go in the denominator as I divide, because division really puts things in the bottom. And similarly over here, if I subtract 20/5 from both sides, I'm going to get negative 29/5, so I'm going to get 29/15. And as I did on the previous question, we can write it with the braces, but we don't have to. So that was number 4 for you. Okay. Now, again, hard enough question that it might be worth taking a look at and making sure you didn't make a mistake. Grabbing that calculator again. If you are not aware of it, the absolute value is found under math. So if you're wanting to know if you did it well, if you go to math and you go over one, the number absolute value is sitting right there. So if you wanted to find out if you had done that problem correctly, you could do so. Okay. Now, we've got a couple of quadratic questions to go through right here. And this one just says solve. So we did discuss in class pretty extensively that our first opening salvo is to do our best to see if we could factor it. Now, on this one, it's a little harder because there's so many ways that you could get 12x squared. It could be 1 and 12, 2 and 6, 4 and 3. There's all these possible answers that it could be. But again, as I've mentioned, I usually just go with a guess that is some central value. I know it can't be a 6 and a 2 because they're both even numbers, and there's no way I can start multiplying even numbers and adding even numbers and come up with an odd value. So it either has to be a 1 and 12 or a 3 and a 4. So as it turns out, if we kind of work our way through, a 5 and a 2 would do it. If I had 15 and 8 would make 7. Notice I got 12x squared, I got 10, but a 15 and an 8 would make 7 if the 15 was positive and the 2 is negative. And that leaves me with my final answer of negative 5/4 or positive 2/3. Now, that's a pretty good one. Now, when we get on to B, we try to, I'll just tell you right now, for the sake of brevity, I tried to factor it. I was just not able to factor it. So the first thing I decided to do is I said, well, everybody is even, so we might as well make the problem nicer. I also noticed that since the problem is not factorable, there's really no point in setting it equal to 0, because really what I'd like to do is my favorite that we talked about, which is completing the square. So I'm going to take this piece right here. I'm going to cut it in half, which gives me negative 2, but then I'm going to square that and add it to both sides. Please remember to add it to both sides. So now we've got x minus 2 squared is equal to negative 9. Now, this is where we call it like playing t-ball, putting it up on the tee. It's ready. All I got to do is take the square root of both sides. So I got x minus 2, but when I try to take the square root of negative 9, I get a 3i because the square root of 9 is 3, but square root of a negative is I. No big deal. And so all we have to do is move that 2 across, and whammo, we are done. That actually was set up to be a fairly nice little question, and it's the first quadratic I've actually done with you guys that actually led to an imaginary answer, although I know you've done them in Algebra 2. And our last one was just this little completing the square story where the numbers get a little bit icky. So let's see what happens. So right away, it says, let's go ahead and follow our process. And we don't like a leading coefficient that is anything other than 1. So I went ahead and I divided everything by 2. And you'll notice that I also moved this to 4 to the other side as I divided it. Now remember, we're going to take 5 halves and cut it in half, which is going to give me 5 quarters. And I'm going to square that, which is 25 sixteenths. Remember, half of 5 halves is negative 5 quarters. We're going to square that. And I got 25 sixteenths, and we are faithfully going to add that to both sides. We can never forget that in math. You can't do it to one side unless you do it to both. And now we're down to x minus 5 quarters squared. This is 32 sixteenths. So that's going to be 57 sixteenths. Now remember, if you can't do that well, grab your calculator, do the math inner thing. It's going to be great. And hey, we're off to the races because now x minus 5/4 is equal to plus or minus the square root of 57 quarters, because all I needed to do was take the square root of both sides. Only thing left is to add 5 quarters to both sides, and we are done with our last quadratic of this review. Now, if you want to put it as a singular fraction, you can. All over 4 or 2 separate fractions, you're okay. Hey, that's it for number 4 and 5. We're done with quadratics. Okay, I'll see you back in class.